This is the design video for SP3 Engineering. We were approached by San Diego State University to try and make the campus a little bit more sustainable in regards to its water usage. My name is Anna Rulon, I'm the project manager. Let's meet the rest of the team.
Hi, I'm Jason Williams. I worked on the wastewater recycle to the cooling tower part of this project.
Hi, I'm Maggie McCormick, and I'm the gray water expert and construction manager for this project.
Hi, my name is Sarah Child. I am the environmental engineering expert, and I worked on the stormwater portion of this project.
Hi, I'm Gabby Hanley, and I'm the stormwater expert for this project.
Hi again, it's Jason here, and I'm here to explain in more detail about our wastewater treatment to our cooling tower system part of this project.
In general, the plan is to take wastewater that the school is currently generating, treat it, and use it for the cooling tower systems instead of potable water, which the system currently uses. Why did we decide to go with this plan? Well, currently the cooling towers, which are responsible for the air conditioning at SDSU, use potable water bought from the city. From our research, we were able to determine that they use an average of 3,049 cubic feet per day, or about 75,000 gallons per day on average. There is no need to use potable water for this system, and we believe we have a viable alternative with the use of recycled wastewater. From our research, we found that the school is currently producing an average of 17,583 cubic feet of wastewater per day. So not only does this project save water, but it also reduces the amount of wastewater the school is producing, therefore saving money on both fronts. When you look at the figures side by side, you can see the school currently produces more than enough wastewater to cover the amount of treated water that the cooling towers could need at any given time. The next step was to determine a suitable location on campus that was close enough to the cooling towers, close enough to the sewer lines that can provide sufficient source material, with enough space to build a treatment plant and all the support structures for it, and far enough away from anything else in order to minimize treatment byproducts like odor. The empty lot adjacent to parking structure 4 is an ideal location because it fits all of those criteria and is also currently only being used as a staging area for other building projects around campus. Therefore, it would not be impacting parking and could be made available as soon as it is not being used as a staging area any longer. The next step included calculating the amount of wastewater that flowed through the available sewer pipes and determining the composition of that wastewater through those pipes. It was determined that there was a sufficient source of wastewater available for this project, and then the wastewater composition helped in determining the treatment plant that would be installed. For the treatment plant, we are recommending the Express Membrane Biological Reactor Packaged Plant by Siemens. It comes pre-constructed and pre-skidded for easy installation, is capable of treating to the containment levels that we have, and can treat up to 100,000 gallons per day. Along with the treatment plant, we will also need to construct a storage tank to hold treated water. The treated water storage tank will be a 200,000 gallon tank. We decided to go with a tank this size to be able to hold extra water for when the levels of water needed by the cooling tower exceed the 100,000 gallons per day that the treatment plant is capable of producing. Here you see rough design plans for the system. There is a gravity-fed 8-inch PVC line that will run from the existing sewer line to the treatment plant. From the treatment plant, the water will be moved into the storage tank until it is needed. There is a pressurized 4-inch PVC pipe that runs from the storage tank to the cooling towers. When the cooling towers discharge water, it goes back into the sewer line that feeds back into the treatment plant, making it an almost closed system. With the additional makeup coming from the other sewer lines that feed into the system to make up for any evaporation from the cooling plant. It is estimated that the total cost of the project will be around $4.2 million. The potential savings of this plan is $400,000. And next we're going to talk about the stormwater portion of our project. And to introduce that, we have Sarah and Gabby.
Sarah and Gabby here.
And we're here to tell you a little more about the stormwater portion of our project.
Currently, all the runoff produced from rainfall events is sent through the stormwater drain system and ultimately is discharged into a receiving creek at designated outfall points. For the San Diego State University campus, there are 3 main outfall points. They are located in the southwest end of campus near the Aquaplex, shown here, another north of parking structure 1, And lastly, in the northeast portion of campus, adjacent to parking lot A, lies the final outfall point. We have designed our system to treat only the stormwater discharge from the outfall point in parking lot A.
The water discharge at this point will be coming from 20 inlets and in-curved storm drains located across the northeast portion of the campus. Clear Water Solutions BMP units, seen here, will be installed at each of these points to filter and treat the water. These stormwater filtration units have been proven to drastically reduce total suspended solids, oil, grease, and other contaminants. Testing was conducted at San Diego State University with these exact units and resulted in removal rates above 90% for most contaminants. Since the stormwater will be treated inline, the water will then be routed through a pipeline from the outfall point to a storage tank located in parking lot A, seen here.
From this pipeline, the water will enter a circular storage tank with a radius of 50 feet and a height of 20 feet, which will hold a volume of 157,080 cubic feet. These dimensions were chosen based on the peak flow calculated using the rational method. Given that rainfall events are rare in San Diego, the volume used to calculate the storage volume assumes peak flow for a period of 6 hours. From the storage tank, the water is pumped through a PVC pipeline and connected back to the irrigation lines at the point shown below. The water will then enter the existing irrigation network and be used to irrigate plants on campus.
Using the peak flow calculated and the average number of storms per year in San Diego, the estimated amount of total stormwater collected per year would be 3,500,307 gallons. Since this water would be used in place of potable water for irrigation, the total amount of money saved per year would be $194,951. The estimated total project cost would be $977,748 with a payback period of a little over 5 years. The last part of the project includes the recycling of gray water produced from the dorms. Anna and Maggie will explain this last part.
Hi, I'm Anna.
And I'm Maggie, and we're going to finish the video by telling you more about our gray water system.
Gray water is wastewater that comes from showers, baths, bathroom sinks, and laundry machines. The area of campus that produces the most amount of this type of water is the dorms. Typically, gray water does not need to be disinfected, but due to the different chemicals used in the dorms, disinfection will need to occur. The gray water can easily be treated by disinfection and reused for landscaping on the campus.
The 4 dorms we focused on include Tenochca, Zura, Maya, and Omega. They all reside in the same area and are close to parking lot G, where our small treatment tanks can be located. Together, they can potentially produce over 55,000 gallons of gray water a day. The gray water will be captured via dual pipes that run alongside the current wastewater pipes. The purple lines in this graphic show where new gray water pipes will have to be put in to take the gray water to the treatment tank. The locations of these pipes were determined based on the existing wastewater pipes already in place.
Once the gray water reaches the treatment step, it will come into contact with 2 microfilters that will filter out particles around 5 microns in size. Next, the gray water needs to be disinfected. It will go into our disinfection tank, which has surface dimensions of 15 feet by 9 feet and a depth of 5 feet. Chlorine will disinfect the water, and it will also serve as an odor control for the treatment plant. There will be a hydraulic residence time of 30 minutes in the disinfection tank. This means that the water will only need to be in the tank for a half hour before moving on to one of the storage tanks. These 2 storage tanks are sized for peak flow. They are big enough to hold more water than the average amount in case more water is used or unexpected problems arise. The water will sit in the storage tanks until it is pulled out for irrigation and landscaping. No water will be in the tanks for more than 24 hours.
Around 3 times a day, the water will be pulled from the tanks and connect to the already existing irrigation lines. The purple pipes shown are the new pipes that will be built for this transportation. This part of the project has the potential to save 55,000 gallons of potable water a day. This means SDSU wouldn't have to pay to import all this water or have to pay to send the wastewater to the sewers, since it will be recycled. 55,000 gallons is half of SDSU's total daily irrigation and landscaping needs. This could save SDSU $211,000 in a 9-month school year. If all 3 of these projects were implemented, the total amount of potable water saved per year would be over 45 million gallons. The total cost to implement all these projects would be around $8.5 million, but the total savings per year for all 3 would be $805,000. The payback period when looking at all 3 projects would be a little bit over 10.5 years.
This concludes our project. Thank you for listening.